We're getting near the end of the unit, but let's have a quick review of some of the ideas related to secure coding concepts. So how can we make our programs secure? Computers, as we know, are unintelligent, and they follow instructions to the letter, manipulating data and interacting with things whether we intended them to or not. As we start to build more and more network-connected devices and network-connected software, our systems are opened up to much more variety of users. And some of those users will want to use our systems in ways that we didn't intend. That brings in lots of potential malicious users. With the right focus, however, we can start to work safely and securely with our code. This is an ongoing and challenging process, but let's have a think about the real basics of security here. The main thing is to keep security in mind when you are building your software. Software is going to be interacted with by lots of people. Or if your software is going to be interacted with by lots of people, then you need to think about how those different people are going to use your system and the implications of that. To start with, adopt the motto, never trust external data. That's probably the key one, as useful not just from a security perspective, but also from a program integrity perspective. Make sure your program works correctly, even if the user is not intentionally doing the wrong thing, they may be providing you with incorrect data. We should validate all inputs to make sure that they are what you expect. Often many of the bugs in our programs are because we don't appropriately validate the inputs that we're getting and to check that they are the right sort of values. In week 3 we had a task related to that where we updated the terminal user input code to make sure that when a user typed in a value, our program checked first that it was an integer, for example, before it tried to convert it to a number. That's the kind of thing we're talking about here. Now, input data, or the data we should check, could come from any kind of input source, directly from the user, from the network, or even from a file that you've saved on your computer. We don't know what values are in these different things. We've therefore got to make sure that any values we get across those mediums is at least pass through some sort of sanity check first. In addition to sanitizing data that we get in, we should look at sanitizing data we send out. So it's possible, for example, with things like SQL injection, to pass SQL strings to other systems and unintentionally update those systems. We've got another video which will look at that. Sanitizing our data to make sure that we only send across valid things to external systems also helps us limit the exposure of our programs to these malicious users. One big challenge is that our instructions are also data. So that means it is possible to manipulate the code that is going to actually execute inside our program. This is where we get things like buffer overflows. That's where we store a value in a variable, but we exceed the size of that variable and enable the computer to change what instruction is going to execute next. If we can do that, then we can start to get the program to do things that we intended that were never actually even coded in the system at all. So it is buffer overflows that enable us to do this kind of thing. Now, many languages can provide us with security features which help hinder these kind of problems. Languages like C# and Java, for example, make it difficult to access values outside of the bounds of an array. And the program would crash if you tried to do that, instead of enabling something like a buffer overflow to occur. So it's worth exploring each language to see what sort of vulnerabilities that language has. Languages like C and C++ have the most because they give you the most flexibility, the most opportunity to make mistakes. Now, with interpreted languages such as Python, sometimes we can get security vulnerabilities not just from the language itself, but also from the language that the interpreter was written in. So in most cases, the Python interpreter is written in the C language. So C++, what we've been using, has been used to write the code that runs all of the Python code. That means there are sometimes vulnerabilities that can be exploited from the actual interpreter itself. Now, they're really difficult to address, particularly when you're writing code in that language. Something to keep in mind. Generally, however, newer and more advanced languages avoid many of the issues because we now know about these challenges and try to build features in to help us avoid them in the languages themselves. So will you be able to secure your code? Once you open your software up to the world, you open your software up to many users. Some of those, this is a great potential, but some of them are going to want to do things that we didn't intend. Try to keep security in mind when you're building your software, but the key thing is this is an ongoing process. Simple things like not trusting internal data, or not trusting external data, are some of the things that we can start to do now in order to help build better software. This is an ongoing concern, so it's something that we develop and we keep looking and reviewing our software to make sure that we aren't introducing security concerns as we go. Hope this has been useful. Good luck with the work that you're doing in the unit.